Okay, guys. Today, I mentioned we're going to talk about number bases. And, so let me try to point this phone so we can get more of the sheet of paper. Because unfortunately, unlike Clive, I don't have my iPhone mounted up on drawer rails. Okay, now we talk about bases a lot, so I'm going to just pitch this up a little bit so you can see. We talk about things usually in base 10, and we can break a base 10 number down into units of 1, units of 10, units of 100, units of 1,000, and so on and so forth, but let's just keep it simple for now. Okay, so I say I have 1, okay, it's one of these units. Now you may remember this kind of stuff from second and third grade, right? That's base 10. My cat's gonna join me here. He's gonna make a jump up here, so you'll see Rusty when he comes up here. And if I say I have, say 15, that'll be 1 unit, bunch of 10, and 1 unit of 5, and it's equal to 15. My pen doesn't die at me. No, it looks like it's gonna hold out. Okay, I hope. Just in case it doesn't, I will do my best to get it ready for you. Yeah, I need another pen. I'm gonna get another pen. Okay. Hopefully this pen will keep writing. Yes, okay, good. So anyway, like I said, let's get back to what we're saying. So I say I have 15, and as I said, 1 bunch of 10, and I have 1 number of block of 5 for 15. Right? If I say I have 100, or say 225, that's 2 units of 2, 100 bundle, 2 units of 10s for 20, and 5 singles. Okay? Okay, that's 225, right? Now, that's base 10. What about other bases? I mentioned binary. Well, here's a quick rule of thumb how you can convert a number base to a number base. There's a formula, but I'm going to keep it simple. 2 raised to the 0 power, 2 raised to the first, 2 raised to the second, and 2 raised to the third. I'm not going to go any more than that because that just gets ridiculously complicated. Or, if I put this in English, that's 1, 2, 4, and 8. Okay? Maximum value is 15. Okay? 0 to 15. So, if I say I have the number 3, because remember, base 2, the highest value that's available is 0 through 1. Base 16, the highest value is 0 to 15. Base 3, which probably will someday be very popular in quantum mechanics, so probably the highest value is 2. But we're talking about base 2 here, so that means 1's and 0. So if I say I have the value of, let's make it a little more exciting. Make it the value of 5. Okay, so 1 and 1, and then of course this is a 0. We need that as a placeholder, and this is a 0. Okay, and I put this over here and hit equal, and that's 5. Okay, now in base 3, we can go by the same thing. After all, I know you guys are excited about that, right? It would be 3 to the 0 power, 3 to the 1 power, and 3 to the 2nd power, and 3 to the 3rd power. Why not? No one ever does base 3. Base 3 sounds like fun. Alright, so let's put those in numbers that we can deal with. 1, 3, 9, and 27. Alright, so now we have, so that's our base 3 numbers. Okay, which means the highest multiples you can have is 2. So let's say I wanted to say I had the number, what is 7? Well, that would be a 2 and 1 unit 1, and these two, using the nomenclature of the industry, would be 0 and 0, which means this is equal to 7. So, that's how base conversions can be done. The rule of thumb is for the formula, it's the base is the unit here, base, and then the exponent, okay? Okay, and in mathematics we say any base raised to the 0 power is equal to 1. Okay, so that means that it doesn't matter if it's base 2, base 5, base 16, base 8. Anytime you raise a single base, in this case if it's decimal, let's slide this up here, I'm trying to keep this in the frame here, of 10 raised to the first 0 power, and you can just send the calculator and confirm it, it's 1. Okay, so you're going from right to left, or left to right, whichever way you like to do it. You will see that you start with the power of, like I did up here on the top. Okay, like I did on the power 2, you go from 0, 1, 2, 3, just like I did down here for the base 3. We have 0, 3 raised to the 0 power, 3 raised to the first power, 3 raised to the second power, and 3 raised to the third. Okay? Now, you can get really ridiculous with base numbers, but there's a realistic limitation. I had a program on my Model 100 and my Model 102 in BASIC that you could enter in the most ridiculous bases you ever wanted. For example, I could say base 32. 32, right? 32. What the hell, how would that be? Well, that'd be similar to when I showed you with the base rate. Okay, so you'd have 32 raised to the 0, 32 raised to the first, 32 raised to the third, and so on and so forth. So ellipses here, ellipsis, ellipsis, ellipsis. So basically, that's how you can deal with bases. Get ridiculous. And normally, in the standard hexadecimal numbers in the nomenclature, and anytime you see a number that's not in base 10, let's say I say a number in octal, say 377, I usually will put in a sub down here a little subscript 8, or in some computers you see 377 O. It's the letter O, not the number. Okay, so that you know that this is not a base 10 number. 377 octal, and I confirmed this on the calculator, is 377 O is equal to 255 in base 10. Okay, so that's the way it works. And you can calculate it yourself if you want to do an octal. You do it the same way I did with the base 3, except you would replace with 8 instead. 8 to the 0 power, 8 to the first, 8 to the second, 8 to the third power. Okay. Roman numerals. As little as I remember about Roman numerals. Let's write these numbers down as I remember. 1, 2, 3, 4 can be written either IV or 1, 2, 3, 4. Okay? 5 is the letter V, or, yeah, if you really want to, 1, 2, 3, 4, 5. Usually the V is used. If you look at most clocks, okay? When you want to increase the numbers, okay, so let's finish here. 6 is VI, 7 is VII, 8 is VIII, 9 is, sometimes can be written that way, or it can be written IX, and then X for 10, and so on and so forth. This system here is what you'll see on your typical grandfather clocks that like to stick with the Roman numerals in the display. Okay? We'll mention the 282K, the letter MM. That means 2,000, because M is 1,000, is like in million, like in milli, or lardo, in Italian, lardo, it's 1,000. Sometimes you see, like if I was trying to write my birthday in hex, I have to admit I have a hard time with certain letters. I know there's an L. I think L is 50. Okay. Yeah, I think it's 50. Okay. Again, those are just a little bit between Roman numerals and number bases. Now, I mentioned that computers and numbers are how we describe things. So one of the questions that came up is, I'm trying to make sure I got a piece of paper so I don't, in case the wind doesn't take my paper here. I got a thick stack of white sheets here. Like I said, and I made a mistake. I said this. I said the ampersand was the letter in hexadecimal of 64. You know, it's the mechanical A, or the at character. Now, it's 64 in base 10. Okay? Or, it's actually equals to 40 in base 16. Okay. And I can find out the octal. I have to look it up though, because I don't really know it at the top of my head. Okay? Now, and I mistakenly said, well, if you got lowercase a, or capital A, because we're talking about capitals here, capital A is right here, and I said the capital A is equal to 65 in base 10, and it is, which is equal to 41 in base 16, which it is, okay? And if you want to get the lowercase, I mistakenly said you have to add 32 to that. I said 64. No, it's 32, because the lowercase a, if is right here, is I take 65 plus 32 equals 7, and like 97. Okay. And 97, that's a 97, that's not a subscript. Okay? Equals the lowercase a. Okay? So, now, using base 16 in hexadecimal, for 256 possible values in ASCII, that covers most everything you're going to ever see in everyday key, except when you're dealing with China and foreign countries like China. In countries that use, and also includes Unicode, is sometimes Chinese talks about something called Big 5, which means what? It's 5 rows, I'll make it easy here, of F, 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 okay, F, and F. Let's see, it's 1, 2, 3, 4, I need one more. F, F, okay, and based on, you can calculate the number if you will, and it's enormous, it's huge. You can just multiply this number, 255 times 255 times 255 times 255 times 255, or 255, or if you want to get fancy, you could say F to the 5th power and subscript to 16. Or, I'm going to do it down here so you can see it now. F, H, lowercase h is quite common, to the 5th power, okay? And that will give you an answer that says the number of possible Chinese characters that can be written in that long of a string. Now, Unicode has the emojis, and the emojis, and probably somebody going to say is, could a number represent a word? Sure. In fact, that's kind of what Unicode does, is things like little pictures, happy, sad, angry, sleeping, laughing, crying, all those are emojis in Unicode, and those Unicode emojis can be represented as a number. I think Unicode is 6 digits up to, so that's another 255, so FF, hexadecimal, raised to the 6th power. It gives a huge number of possible choices. In Braille, we use, in grade 1.5, we use letters to refer to words. For example, B for but, C for can, D for do, E for every. I'm trying to remember my grade 1 Braille here, or grade 2, 1.5 Braille. F, used sometimes is used for the word for, but not as much as it used to be, because we've replaced that with another Braille symbol, but I guess you can say for. Yeah. Yeah. Okay. And there we go. So now I can actually write even in English using the same kind of language. I guess Y could mean you. The letter U could mean us. Like, me, us. And the point here is all these different systems is to learn to read numbers. The most important thing is a number is a symbol. Let me just write that kind of in a shortcut here. A number sign is a symbol to describe, okay? To describe. Okay, so if I said I have 5 marbles, like I said yesterday, or 5 sheep, I'm just going to just draw 5 S's to represent shape, okay? Here's my little corral, okay? And I have 1S, 2S, 3S, 4S, and 5S, okay? So I have 5 sheeps, or 5 S's. And if I say, how many S's do I have? I can count them. 1, 2, 3, 4, 5. Now either I can draw it like this. I'm showing it on a piece of paper, which is kind of crazy. Or I can say, I have 5 S's. Or in this case, S's represent sheep, so I'll use the word sheep, okay? Now, so because it's a symbol, or it can be used to describe a quantity or anything like that, that is how we can use the system to do bases. Very simple. It's just, it's not correct. So, anyway, let me see if this pen starts writing it. Now it writes again. Okay. If it lets soak up some ink. Alright. So now, if you want to do base conversions, can most calculators do foreign bases? If you have a calculator that has an X, Y key on it, well, scientifics do. The answer is yes. Okay. So when you write your chart, you would use that key to enter, so let's say base 3. You already know that the first base is always going to be equal, a little higher up, please, 0, is always going to equal 1, okay? And if you know, times table is keeping it simple, 3 to the first, or 3 times itself, simple enough, is 3. And if I say 3 to the second power, 2 is equal to 3 times, just what that means, 3, which equals 9. And if I say 3 to the third power, 3 to the third equals 3.3.3, which equals, and you can calculate yourself, 27. And you can do 3 to the 4th, 3 to the 5th, 3 to the 6th, either by multiplying by a long way or by using that key I told you up here, the XY key on your calculator, and it will individually give you your base numbers so that you can write them in to your chart. Okay? Very simple. In most of the time, though, most everyday world, you work with either, okay, these are the most common bases. Okay, base 10, base 8 is sometimes used in the trades, base 2, and base 16. Okay, maximum values of base 10 is 0 through 9. 8 is 0 through 7. Base 2 is 0 through 1. And base 16 is, this one gets fun, 0 through F. Sometimes it's written as lowercase, sometimes it's written as uppercase. It doesn't really matter. So if you see it anyway, 0 through F, it means the same in nomenclature when you see a number written. For example, if you don't see a letter like F in a thing, you can assume it's almost always assume it's base 10. But be aware, 20H or sometimes 2016 or, I might as well mention this too, because sometimes you see capitalized, 20 capital H does not equal, okay, so not equal to 20 in base 10. What it equals is, it's equal to the value of 32. Okay? So you can do the base conversion like that. Now, I hope that helps you to understand when you're trying to learn to read number bases. I don't really know why Taco Man asked that question yesterday. I tried to explain it, but I think I did a better job with the paper. But you know what? Let me say this right now. Let me just turn this way up here. Yeah, well, you know what? Yep, there we go. Oh, let's raise this up here a bit. Base conversion is one of the things in mathematics that you will run into a lot. You use, especially in the computer field, you mention base 2, especially in embedded things such as controllers. We need to calculate the AND, OR, XOR, and NOT gates truth tables. You also see base 16 used in the same trade to represent things as well, because it's really convenient. Let me show you that real quick here. If I take, I'm going to write this down here, 0, I'm going to make it bigger, 1, I'm going to write these in decimals so you can see. Actually, this is text, but 3, 4. My pen's down again. 4, 5, 6. I'm going to start with this, and it goes all the way to F, okay? If I was to write 0 in some way in 4 units of hex, right? 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, and 6 would be 0, 1, 1, 0. So, okay, so let's go to the not so expecteds and the hexadecimals. Okay, I'm gonna go straight to the value of 14, which is the letter. I might as well do letter 13 because that confuses people. Which is usually is represented in lowercase d, but it could also be in capital D too. Usually it's in lowercase because they don't want to get confused with 0. So D, E, and F. So in 13, so what we have to do is already said that if it's 0, okay, because 2 raised to the third power is 16. Calculate yourself. 2 times 2 is 4 times 2 is 8. Oh, so it's 8. I'm sorry. Okay, so that's 1. Okay. And then I have, so that means I have 13 to go. Which means we probably have the value of the 4s. So now we're up to 12. And then I have 0. And then I have a 1. Then CE would be 1, 1, 1, 0. And F is just 1, 1, 1, 1. So using the letters, you can imagine the switch bases of how that would work. So if I said I have the value of F, and I can break it down into 2 bundles, or what they call nibbles, of 4. 1, 1, 1, and 1, 1, 1, 1. So, because it's a shortcut. And then actually, it makes it easier for base conversion. This can be used for almost any kind of base conversion. But, as I said, this is usually the way sometimes you see hexadecimal numbers are being used to represent switch states, saying dip switches. And if you know how to read those dip switch numbers like this, it's a real breeze. But if you can't, and a lot of people don't have the ability because they don't know how, it gets a little more challenging. Well, I hope this helps Taco Man. And you can experiment with number bases. They're actually kind of fun, because you can actually visualize how the early encoding with the Germans worked using number bases. Likewise, you can imagine how RSA 128-bit ciphers work and all that. It's just using a lot bigger, complicated numbers. So, quite cool to imagine how that works. Alright, so for now, thanks for watching this, guys. I hope this helps you out in your studies. Okay? Bye-bye.